I'm A. Nirisha, Assistant Professor in the Department of CSIT, working in MLR Institutions of Technology. Today in this lecture, we are going to discuss about union, typedef, and also the self-referential structure. So we are going to see about the unions, typedef, and also the self-referential structures. So here coming to the union. Union is also same as the structure, but we have some differences. We'll watch out that differences. So in a C programming language, union is a collection of elements of different data types. The union is used to create user-defined data type in the C programming language. So it is also used to collect the different data type elements as structure. But the union is an user-defined data type. Union is also said to be an user-defined data type in C. So in other words, union is a collection of non-homogeneous elements, which means heterogeneous elements, which means different elements, different data type elements. Using union, we can define new data types called user-defined data types that hold multiple values of the different types. And here the formal definition is it is a collection of different type of elements under a single name that acts as a user-defined data type in the C. So coming to the union declaration. Here we are declaring the union by using a union keyword. We are declaring the structure by using a struct keyword, and we are declaring the union by using a union keyword. So here the syntax is union, its name, and how many members you want to add, that many members you can add inside this open and close brackets, and it should be end with the semicolon after the flower brackets. So here, for example, the union of a student. For example, we can create the union called student, which is used to hold the student record, like union student, and here we can give int roll number, and the next char name of that particular person contains 20 characters, and the next float marks. So such type of information, or whatever the information you have requirement, so all that things we can store in a union. So this is the example of a union declaration. So how we are declaring the union, it is same as the structure, but the only thing is here we are using union, and in the structure we are using the structure keyword. And coming to the memory allocation, there is also a difference in the memory allocations that we'll check out. So memory allocation of the union. When the unions are used in a C programming language, the memory does not allocate on defining union. The memory is allocated when we create a variable of a particular union. So as long as the variable of a union is created, no memory is allocated. So the size of the memory allocated is equal to the maximum memory required by an individual member among all members of that union. So take an example of this union student here. Char student name, some 30 bytes, 30 size we have given as a 30. So which means 30 characters can hold this name. And the size of int is 2 bytes if you are using 16-bit compiler, and 4 bytes if you are using 32-bit compiler. And the next for percentage, the float data type we have 4 bytes. So here this has the 30 bytes. So the name has occupied some 30 bytes to store that particular name. It's the characters to store that characters, and 2 bytes are used to store the integer value, and the 4 bytes are used to store the percentage of that particular student. So here out of this three, the largest data type is 30 bytes. So that only 30 bytes of memory will get allocated to this particular union whenever we declare a variable. So until and unless we declare a variable, the memory is not going to allocate. So whenever we declare a variable, the memory will get allocated here. So here, instead of allocating memory to all the members, which is the member which has the largest data type, so for that particular largest data type, how much capacity of memory is there? So only that much memory will get allocated to that union. So here the memory is being shared by all the members. So here the student union is allocated with 30 bytes of memory, and it is shared by all the members of that union. Next is a typedef. So here typedef is a keyword that is used to provide existing data types with a new name. So here the C typedef is used to redefine the name of already existing data type. So for suppose if you want to change the name of the existing data type, then you can change by using this typedef keyword. So this is the syntax: typedef existing name and alias name. For suppose we have a data type called unsigned long int. So here we have some three words. So these three words can be replaced by using a single word called unit by using this typedef, or whatever the name you want to give instead of unit, whatever the name you want to give, you can give to the existing data type by using this typedef keyword. And also we have for the struct, we have struct to complex. So this struct to complex also we can change, the data type can be changed to the number by using this typedef keyword. So whatever the existing data type that we have, we can change that particular data type name by using this typedef keyword. So instead of writing these three words, we can write only the single word and it will be easy to access. And the next, say this is a header file, and next is a typedef unsigned int, we are changing into the unit. Unit is now an alias name of unsigned int only to this particular program, and we are not changing it entirely completely. And the next, typedef struct. So int x, int y, and this typedef struct is being changed to the name as point. So we are changing the type structure point to the point. And the next, int main. See here, unit num is equals to 42. So here uint is nothing but the data type of unsigned int. And the next, point b is nothing but the structure point. And the next, by using this printf statement, we are printing that value. And the next, by using this printf statement, we are printing the x and y coordinates of that particular structure. So which is nothing, typedef is nothing but we are changing the existing data type names. And the next is a self-referential structure. So self-referential, the structure referring itself is called as a self-referential structures. It is mainly used in data structures. So while you are building this linked list, trees, graphs, at that time the self-referential structure will be used. So the syntax is struct name, and here we have structure name and a pointer variable, and this pointer will point to the same structure. So this is an example: struct node int data. So one data value we are storing, and next to that data value we have one pointer variable, and that pointer variable is of structure same type, same structure node type. So that is pointing to the same structure itself. This referring itself is called as a self-referential structure. So one of the example program for this. So here we have header file, and the next struct node, to the struct node we have one data value and also the one pointer value. This pointer value will point to the next node. So a node consists of two fields. In a linked list, a node consists of some two fields. One is the data field and the other one is the address field. So data field is nothing but the actual data that what we want to store, and address field is nothing but the next, it points to the address of the next node. So a linked list is nothing but a list of nodes. So consider these are some list of some three nodes that we have. So here we'll have the data value, and here we'll have some address, and here we'll have data, and here we'll have some data. So consider that data is 10, 20 and 30. The name of this node is A, name of the node is B, and the name of the node is C. So consider here the address of that particular A node is starting with 1000, and this is starting with 2000, and this is starting with 3000. So thus in the address part, which is nothing but in the link part, will have the address of the next node. The address of the next node is 2000. So the 2000 will be placed over here link, and that this will point to the next node. And in this address field of the B node also, which is nothing but link field, that also will have the address of the next node. The address of the next node is 3000. So the 3000 will be pointing to this C node. So if you want to stop this link, so the last node address you need to assign with the null, so that the linked list will be stopped with this three nodes. If you want to extend the next node address, you want to add in this address field. So this is about the we can this nodes and this linked list we can create by using a self-referential structure. So here they see here structure node OB1, OB2 and OB3. See, this OB1, OB2, OB3 are nothing but the variables that we are creating of this structure type. So to create a node, here we have taken this A, B, C, A node, B node, C node. So in the same way, we are taking the node names as OB1, OB2 and OB3. So here OB1 data we are taking it as 10. So the 10 will be placed over here. And next OB1 dot link is equals to address of OB2. So this is nothing but the OB2 and this is the OB1 and this is the OB3. So the node names. So it is address of OB2. Address of OB2 is 2000. 2000 we are placing in the OB1 dot link. So it will be placed over here. And the next OB2 data 1 is equals to 20. And the address of the next node we are placing in the OB2 dot link. That is address of OB3. We are placing in the address of that second node. And the next OB3 data is equals to 30 and OB3 dot link is equals to null. So we are stopping our linked list over here. The next, by using this printf statement, we are printing this OB1 dot link dot data. In OB1 dot link, OB1 dot link. So how we are accessing this structure members? By using a dot operator. OB1 is the variable that we have created to the structure and link is nothing but the member that we have in that particular structure. So that OB1 dot link is pointing to the data 1. So which means it is pointing to the data or data 1 of this next node. So the 20 will get printed over here. And the next OB2 link dot data. In OB2 link, what we have? The 3000 we have. So by using this arrow mark, we'll get the value that is present in that particular data. So the value that is present in the data is nothing but 3000. Sorry, 30. So the 30 will get printed over here. Thank you.